You've asked for it, so here it is. Real number operations, multiplying and dividing surds. So let's recap from our last video. First, remember that any terminating decimal is automatically a rational number. Also, any recurring decimal is going to be a rational number. Our irrational numbers are non-terminating decimals which do not recur. They go on forever and they never repeat. Our surds are a special type of irrational number which can only be written exactly with a root sign, and the type of that root sign doesn't matter. Square root, cubed root, 7th root, 10th root, they can all be surds if that's the only way to exactly express them. So let's start to move on to how can we do things with these surds. At this point we've got to remember that surds are numbers, which means we can express them in multiple ways and we can do things with them. And here we can think about our operations. We can add them, we can subtract them, we can multiply or divide, we can chuck them in brackets, we can raise them to different powers. These are numbers. All we have to do is learn how to use them effectively. So today we're going to start with multiplying surds. And we're going to throw back to year 8 when you're learning how to multiply algebraic expressions. So if we were given 3a times 2b, we now know we can first deal with the coefficients, we multiply the 3 and the 2, and then we deal with the pronumerals, we multiply the a and the b. The surds will work in exactly the same way. If we're presented with 3 root 2 times 2 root 5, first we deal with our rational components, we'll multiply the 3 and the 2, and then we deal with our irrational components, the root 2 and the root 5. And let's look at this example in detail. We have 3 root 2 times 2 root 5. So we're going to expand that out to show just all the multiplication signs that aren't necessarily shown here. We have 3 times root 2 times 2 times root 5. Since multiplication is associative, we can change the order of these terms and the order doesn't change anything. So we'll put the rational components first, that's 3 times 2, and the irrational components second, which is root 2 times root 5. We can then evaluate these components separately. 3 times 2 is 6. And when we multiply the irrational components, we multiply the numbers inside the root sign. We can do this because it's the same type of root. So root 2 times root 5, 2 times 5 is 10, root 2 times root 5 is root 10, and we wind up with 6 times root 10, which is 6 root 10. Dividing surds works in exactly the same way, and we're going to adopt a similar process. Here we have 4 root 6 divided by 2 root 3. We're going to deal with simplifying our rational components first. 4 on 2 simplifies to 2 in the numerator, and then we have root 6 over root 3. And using the factor knowledge that we have from multiplying surds, if 6 can be expressed as 3 times 2, then root 6 can be expressed as root 3 times root 2. And now, using our knowledge from algebra, we know that root 3 on root 3 is 1, and this simplifies down to 2 times root 2, or 2 root 2. The most common error that we see at this point is when people try to simplify a rational component with an irrational component. So someone might try to cancel the 2 with the root 6 and they wind up with 4 root 3 over root 3. That is incorrect and we can never do that. And that's because root 6 is not 6. It is different. It is a different number. And trying to simplify in that way with the 2 just doesn't work out mathematically. So let's start to recap for today. First, remember surds are just numbers, and that means we can do things with these numbers. When we multiply and divide surds, we think about algebraic expressions, we throw it back to year 8, and we apply the same principles. First we deal with the rational components, and then we deal with the irrational components. Ta-ra, and this has been how to multiply and divide surds. Thanks for watching, and we'll see you in the next video.